All right, thank you, everyone. We're in the home stretch. It's my pleasure to introduce Dirk Peterson, the Director of Scientific Computing at the Fred Hutchison Cancer Research Center. And the topic is Getting to Zero, Funding Cures with Zeros and Ones. Thank you, Dirk.
Awesome, thank you. All right, so let's talk about what we do at Fred Hutch. I'm a scientific computing director, which means that I'm basically responsible for everything and nothing, and everything that falls by the wayside often lands on my table. So Fred Hutch is an organization. As you can see, we are curing cancer while riding our bicycles. And have you seen Obliterate? It's actually a must-have. You can sign up once a year to do an awesome bike ride to actually help curing cancer. And the Fred Hutch is an organization with 200-something independent research groups. We are mostly grant and gift funded, which means it is your tax dollars at work. And we deal with cancer and infectious diseases, mostly HIV. So cloud, I have to admit, we're newbies, so nothing that I'm going to talk about will give you any fantastic technology revelations, because we just started in 2016, which is just last year. We are, when you read the Cloud for Dummies documentation, it says mostly focus on one cloud provider and get really good at that. And we said, nah, we don't need that. We want them all. We want all the candies in the candy store. And today we are doing the orange candy and the blue candy, but we're focusing a little bit more on orange. So orange is still very tasty for us. We have a cloud-first strategy. What that means is you have to bring a justification for not doing cloud. So when you say, here's a project, and I think it would be most awesome to install computers in our data center and do that all this way, and here's the justification, you can do that, but you could meet some counter arguments from your colleagues, and they would say, well, I don't believe that. I don't believe that your plan is sane. We should actually investigate cloud more and do the analysis for that. So that's cloud-first strategy. Whenever we do something new, we set it up in the cloud. Roadmap for us is, as given a goal by our CIO, Matthew Trennell, is 5 years that we want to be all cloud, or let's say 90% cloud, but in that neighborhood, that we have moved all of our operations to the cloud. Today, we are at about maybe 85% on-premise, maybe a little bit more. The one example that we have built at Fred Hutch is an organization called the Hutch Data Commonwealth, HDC, and we came to the realization at some point that new infrastructure, big data resources, technologies cannot be provided by a single researcher anymore. They can't actually deliver the resources, the funding to build huge infrastructures. And HDC is an organization that will bring this infrastructure to the community. So it's a platform that will benefit many. My colleague Naveen and Ram asked me to show a little bit about what they're doing at the Hutch Data Commonwealth. So Naveen is our principal, our head of data science, and he's working in machine learning, language technology, so chatbots, image analysis. For example, one of the projects is data mining in colorectal cancer. Another one is information extraction and structured biomedical data, quote unquote NLP projects. And here's Ram. And Ram is really into deep learning for medical image recognition. And does data science for a cancer immunotherapy. And so if you're interested in talking to one of them, please don't hesitate, send them an email. They're really interested in collaboration. So how have we, how can you frame the road to the cloud, or how can you frame your own success stories, and how can you do it? I asked the question, how have we been liberated by the cloud? What has really changed organizationally? You can always say, okay, you can provision things faster and better and more ad hoc, but what does it do to the people who actually work with cloud computing? And one of the things we observe is we observe an uptake of risk-taking. We see that our staff is no longer concerned about a 5-year plan. Right? So normally when you install an infrastructure, it has to be good for 5 years. And if you only make it workable for only 3 years, then you have kind of already failed. So normally you're very careful about making these plans work. And so 5-year plans, that is often a little bit, you remember, like, this is kind of the Soviet Union, right? They had to make 5-year plans, and often these 5-year plans, they didn't work out in year 3, 4 anymore. And so we're on the same thing. So we can, basically, we don't have any capital investment. You're not getting scolded for making a mistake in the sense that, oh, here you wasted $100,000. No, you deploy everything to the cloud, and if it doesn't work, then hey, try something else. That's great. Also, what the ability to create like test environments or to try something out does to people is they accept software that is probably not up to standards. And that's really important in nonprofit, especially in research. We are dealing with software that is not perfect. It's sometimes even not very good at all. And so to run this software, you have to be willing to have a certain motivation for risk. And if you can develop a test environment that actually proves that this non-perfect software is working well for you, then you may be okay. You can bring the evidence. It's working for this specific use case. We don't care whether the software has deficiencies. And then the third thing is the cloud stability. So I want to take the risk, but my cloud provider, like AWS, is not supposed to do that. They are providing me with an API that where tools that have been developed in 2009 and 2010 are still working. When I make this investment in a certain workflow, that may be a workflow that is there to stay. And I don't want to necessarily change that anymore, so I need to have an API that is stable. And that, I have to say, worked incredibly well so far. Even though we're not in the cloud for many years, we've seen the stability in the API, sometimes over 5, 6, 7 years, and that's really great to know. So the other thing is infrastructure as code. There are a lot of tools, add-ons, wonderful things you can buy to make your life easier, but we felt that Git, a source code repository, and GitHub as a workflow add-on to that, a tool called Terraform. You can also use CloudFormation, and higher level tools that actually deal with operating system configuration really is all we really need. We've had great success with that. And the other thing that I'm passionate about is you can have a documentation or your code as documentation. If your code is good, you can use it as documentation. But if you do need documentation, just put it with the code, put it all together so people can find it and it's not on some website somewhere that nobody can find and see. A specific example is how have we been liberated is proteomics. So proteomics is the research field that where we hope that we can actually detect cancer early enough so that it can be treated quickly. So before you even know, before you have any of the first symptoms, you can find some signs of cancer in your body, and proteomics is the research field that hopes to reveal that. And we are still in the earliest stages for that. Funny enough, proteomics works only on Windows computers. Almost everybody who works in the field writes code that works on Windows, which is really interesting. Because the research, in general, research computing is very largely Unix-based. And so we've been dabbling with that a little bit because you have to, in order to make computing work for people, you have to actually install Linux machines, Windows machines, and then they are not used that much. And so this is a use case where a software called MaxQuant, it can take all the CPUs on a 60-core machine, or even a 100-core machine, can make them run at 100% for 3 days, and then you shut it down, and then you leave it. So this was a great experience for us. It's one of my favorite examples for, so if you don't believe in cloud, this is the example that really makes you believe in that, right? So we can rent the largest machine at Amazon. It costs like $20 an hour, but yes, we're only using it 15 times a year, so it's not a huge cost, right? But this would be a machine that you would normally pay $25,000 for. And so it's a fully automated thing that also takes into account that the workflows of our end users, so they are logging into a Unix machine, they submit their jobs just as they do with other jobs, and then in the background something magic happens. And as you can see, it's very much based on Amazon core infrastructure such as S3. And you could do this much more elegant with other things that are out there, but this was just an easy example. Another really exciting project is in Hutch Data Commonwealth is the Haiku IQ. And Haiku IQ is a project, a program where we deal with health economics. So you know that the healthcare costs in the United States on average per patient are about twice as high as in any other developed country, or even more than that. And so Haiku IQ gets a lot of data from multiple sources and then brings up this website as an analysis tool mostly for healthcare providers. Again, it's in the very early stages. And during conferences or during certain events, the usage increases dramatically. So we have a full stack with every JavaScript tool you can imagine what's been developed, and we're using MongoDB as a database, and then deploy this in AWS. It's been working very well. Little side information, so we had 2017, and what we found interesting was that apparently there's no example anywhere in the internet how you can build a MongoDB cluster securely. We were really surprised about that. Couldn't believe it. MongoDB has been around for years and years and years, but obviously most MongoDB users do not care that much about security, and if they care, they do not obviously document it. So here's an end-to-end example how you install a MongoDB cluster in our GitHub repository. So if you know the English language and if you know how to type, you can become a MongoDB administrator now, and that has a secure database. So that's one example. Since we are funded by tax dollars, we really believe in sharing the stuff that we do. So if at all possible, we do some work that is in some ways value add. So if we don't find anything on the internet that any other person did, then we try to share this if we spend like a week or two on figuring this out and put it all in our GitHub repositories. Talking a little bit about S3. S3 has been out for a long time, and people don't really think that it's probably that exciting to talk about it anymore. But I do believe that we're getting to a point where, since it's been around for such a long time, that we are at a maturity level and an adoption level where really, really more and more people are using it who haven't been using it in the past. And that is really exciting. So for example, when we get genomic data, there's like multiple centers around the country that sequence genomic data, and then we download this genomic data. We have now, for the first time, had the offer from somebody who does this kind of work. Hey, we can actually put it on an FTP server, which we've done for like 10-something years. Or we just put it into your S3 bucket, and you can download it from there. very fast at the location that's closest to you. And so very exciting that we are now able to actually have this kind of workflow with our sequencing centers and just rely on S3. Other examples for S3 is if you have a Hadoop cluster and you want to use Hadoop, then you always have to have a file system that's specific to this Hadoop cluster, and that's kind of not very well integrated with all the rest of your data. And Amazon has a tool called EMRFS where you can actually expose S3 storage to an Hadoop cluster and make that work very well. It's not as fast as the other one, but it achieves about 50% of the performance, and that is often enough for integrated workflows to function. So I'm really excited about that. S3 is also a compute platform for external research. For example, there's a grant-funded project called Globus Genomics, and it works entirely on AWS. And so you have like certain toolkits where genomic analysis is often working on the command line, and there's a lot of people who don't like that and would like to have it in a web browser. And so it uses a toolkit called Galaxy and makes that available to users. And it's very well integrated in AWS, and it uses your S3 bucket. So if you already have your data in S3, or if you want to put it there, your investigators can directly go to this website and then say, hey, this is my data, it's in S3, and here I have it. I don't have to upload it. I don't have to move it to another place. The same with, for example, with AWS Batch is a new platform that we started to use. It uses like Docker containers that are integrated with AWS, S3, and Lambda to do computations. And again, you have all your data already in S3, you know how to access it, and then you just feed it into this pipeline. So it's an easy process. So talking a little bit about, so I'm very excited about Amazon S3. I'm very excited about object storage in general. However, there's still, if you look at the average population or at large users, there's still a tiny fraction of people who use it. It's still perceived as cumbersome. So if we, for example, you see here an email exchange with that genomics center that was transferring this data, and the number of emails that were required in order to get S3 working was very astounding. So I attribute this to a change in process. So every process that you learn, if you're starting to use an FTP server for the first time, you will also say, oh my God, this is terrible, this is terrible. But then 20 years later, everybody knows how to use an FTP server and nobody talks about this anymore, right? And so we're kind of at this point. A lot of people have really no good idea how S3 functions. So there's no first question, there's no folders. There's just buckets. The buckets have no real subfolders. Well, they have subfolders, but they don't really exist. When I do have to do something with some tools, I have to download the data first before I can do something with it, and then I can't rename my files. I just can like delete them and overwrite them and do something. So it takes some training to get used to it. So that's really one of the things. And here's another example. So if you don't know how to use it, well, then you're sending an email to your helpful computer people. And then you mark the stuff that has to move to there, and you mark something in yellow, you mark something in green, and you mark something in red, right? So the customer here is a very accurate scientist, right? So everything has to work reproducibly and repeatably, and so, you know, but needs some help in organizing the data. And that just shows that we are not quite there yet in end-user adoption. So what's next? Cloud computing and research. It's a little bit, what is next? What's the trend? I could tell this now, and it's also a list of what I want. And so one of the things that I think is getting excitement is faster VPNs. In biomedical research, we are often regulated by HIPAA requirements or by other strict requirements, and we can't just ship our data through AWS Direct Connect. We always need like an encryption layer, and these encryption layers are just too slow today. And so layer 2 VPN is some of the things that probably can help us with that in the future. Another thing is traditional old-school POSIX file systems are prevalent in AWS, are prevalent everywhere, but they're not really prevalent in the cloud right now, at least not on a cost-effective basis. So that is also going to happen. And then, of course, other alternatives to Docker. Docker has been dominating the market for a while, but there's a lot of other exciting areas. And if you want to read about the exciting things, I always love to look at the Next platform, which is my favorite website. So with that, thank you very much. You can send emails to Naveen, to Ram, or to me if you're interested. And if you have questions, now do we have time for questions?
We don't have
time for questions.
But
okay.
I've got good news for you.
Okay.
We're going to do a panel with you on it. So if I can introduce Mia Champion, a senior data scientist, she is going to be our panel moderator.
Okay.
And Dirk, if you can stay on stage to answer questions from Mia, that would be ideal.
I will be happy.
Thank you.
Eric and Meredith. Yeah. Thank you. Thank you, Dirk, for that great talk. And thank you, everybody, for attending this next session, staying on for the Healing Powers of Technology panel. So as you know, Dirk Peterson is the Director of Computing for the Fred Hutchison Cancer Research Center. And we have a couple of other panel members, I think, that are going to be coming up to the stage. So we have Eric Tom, who's the Chief Research Information Officer from Seattle Children's Hospital, and Meredith Sloda, Principal Product Manager at Sage BioNetworks. So please welcome our panel guests here. And
Hi there. Hi.
okay, so I will kick us off with some questions for our panel, and then we're going to open it up for the audience. And we just like to ask that when you ask questions, please use the microphone so that everybody can hear. So I will kick it off with a question about data. So we all realize that a lot of the discoveries that we're capable of making in research are really determined by what data sets the scientists are using to analyze. And so how has the cloud computing changed the way that data is accessible and able to be aggregated and analyzed by the scientists, the scientific researchers that you work with, while ensuring that it remains secure and that ownership is still clear, especially when we're talking about data sets that have sensitive patient data associated. So, turn it over to you.
Do you want to start?
I can start. So, thank you for having us today. For the Seattle Children's Research Institute, our institution is about 10 years old. We just celebrated our 10th anniversary. We're just down the street, neighbors to Amazon. The hospital itself is over 100 years old, so we've been on different growth paths. And our IT infrastructure was really built for a hospital to be secure, to be up 99.9% of the time, while research is much different. We want to fail fast, try things, scale things up quickly, and then move on to the next thing if it doesn't work. When I arrived, really the infrastructure was set up for a hospital instead of for research. And we really looked to the cloud as a way of accelerating our research. And so we started with some SaaS solutions that were protected, had HIPAA protections around them that were built on AWS. One of them was Genospace, built on AWS platform. That was a startup based in Boston where we could bring in our clinical data, de-identify it in a HIPAA compliant environment, and then allow our researchers to start exploring the clinical data from our electronic health record. The other piece that we didn't have, Dirk mentioned in his talk, Globus genomics. Again, we didn't have high performance computing cluster. Actually, our researchers, a lot of them went to the Hutch to borrow their cluster, or the UW to borrow their cluster. And really to get the first genomic analysis within our own institution, we again looked to the cloud and used Globus genomics based in AWS. We've done some early pilots. It's actually about 2 years of piloting with AWS as an infrastructure to build up a Hadoop clusters, partnering with, I'm blanking on our distribution right now.
Cloudera?
Cloudera,
Yeah.
sorry. Cloudera to build what we're calling a integration of clinical and genomic data with a GUI interface. And we've codenamed that Rainier. So we're really, early pilots, again, able to just scale up clusters very quickly on AWS in a secure manner.
Excellent.
Yeah, and I'll piggyback on what you said to say that the issues that you were experiencing at Seattle Children's are also endemic to research, right? The procurement of software, procurement of hardware is historically quite challenging, expensive, hard to change once you've picked a path. And so the ability to work in the cloud does enable researchers a lot more flexibility in choosing their technology and, more importantly, in changing their technology if it's the wrong path. And I think there's a lot of fear around picking that technology path, and having cloud infrastructure makes that a little bit less terrifying. And so as the product manager for Synapse, it's a data sharing and collaboration platform targeted at researchers that is produced by SageBot Networks. And one of the key things that we were trying to solve is the ability to work on shared data sets across institutional borders with privacy protections for sensitive public or sensitive private data in place in a sort of understandable way, because that's also challenging. It's not sufficient enough to sort of apply protections. You also have to communicate what those are and tell your users what to do. But then being able to work with data without having to physically move it everywhere is also just, I don't think it's possible to overstate how important that is, to be able to say, work with a giant data set without downloading it, without emailing it to somebody, without putting it on an FTP server. These are all norms in the research community that are alive and well. But I think it's moving, and tools like S3 and being able to sort of do distributed computing are all, I think, beginning to change the industry as we know it in the research space. And that's super powerful, and I don't even think we know quite how powerful yet.
I think that also, I was just advocating, yes, put everything in S3 and use one source for all of your data. And that is, of course, as we all know, it's probably not 100% realistic. There's always going to be some transformation where that is not possible. But I do think that there's better tools now to make this data transformation automated. Right? So if you're looking at just the ETL tools that come alive in Amazon right now, or you take Athena, Presto, all these additional tools that allow you to work at a much greater level of automation and still keep the data kind of integer and not having to manually move around. But as soon as you have manual processes with your wonderful and secure data, you're always running the risk that it's not as wonderful and not as secure anymore, because it's moved by someone somewhere, right?
So picking up that thread and also sort of keeping with the theme of the conference, that's the Imagine a Better World, we've heard a lot during this conference about just how complicated data sets are getting, right? And you've all just touched upon that. It's not just integrating genomics data, but now electronic medical records, other types of patient, maybe real-time patient monitoring. We've heard some at this conference about IoT devices and things like that. And in thinking about data as sort of an endpoint, right? You're never gonna have all of the data sets in one place. What are some of the things you'd like to see in thinking about the future cloud computing enabling in that regard, or some comments about where we're going basically with that?
One of the things I will say, and this is, I think, from the research perspective, but it probably has other applications, is that for a researcher, data only has any kind of meaning if it's contextualized. And so this sort of, I think you were talking about processes and people and processes being really important. Being able to communicate that and document it in a meaningful way helps make that data become a reusable resource, because then other people can interpret it. And so when I think about where we want to be going. I think enabling that data to be meaningful and sort of well annotated, whatever that means in that context, so that another person can pick it up and continue that work instead of having to start from the beginning. This whole idea of research building on itself over time becomes quite challenging if we just have meaningless, huge data sets in the cloud without any knowledge about where they came from, who made them, what they were doing, what they used, and maybe even their initial thoughts on it. And so I think that that's where, when we think about making data useful in the cloud, we need to think about it from the intended reuse or even unintended reuse of that data and being able to really make sense of it. And that's something that is sometimes missing when we're talking about really powerful storage systems or compute systems, or they're missing that key research criteria where context is everything.
I'd like to see fewer identities that I have to deal with. We know that as a human being, when you browse the internet or if you're doing anything, you probably can't handle, how many passwords can you handle? Maybe 10 or maybe 15. I can probably only do 5. And so to reduce that, so if you really want to ask me for my biggest wish, it would be Google, Microsoft, and Amazon get together and agree on a common ID, right? So that you have a ID and password that everybody can use. So that's what Sage Bionetwork basically does in a small scale, right? So you have your Sage ID, and then everybody can basically use the Synapse ID, and everybody can basically use that and share with other people where I know their Synapse ID, right? If I want to share with you, then I know your Amazon ID, of course, but if I have the data somewhere else, then I can't share with that Amazon ID. I need to know your Google ID or something like that. So that would be my biggest wish, that they all agree on one ID. Can it be done this year?
Well, there's certainly growing interest in technologies like blockchain authentication and other methods that I think might help in that regard. Did you want to also?
My dream would be, it's not very sexy, but to have compliant solutions. So we work in a HIPAA environment, and for working with different cloud vendors and Amazon, Microsoft, Google, it's really hard to get, we spend a lot of time with our security officers and our lawyers getting compliant solutions, both from a HIPAA perspective, just up and running. It's easy to just turn on the server, start loading data up into it, but really to have it in a HIPAA compliant manner. And Amazon does provide a lot of resources to support that, but it still takes a long time. My other wish, as we are building a new research facility, there's a big hole, just like Amazon's big hole, we have a big hole down the street, and our new building Cure, at the top of it will be what we call our Cure factory, which will be a GMP, a good manufacturing plant, process manufacturing, essentially cures for cancer. So we have a research program right now where we take the immune systems of kids, reprogram their T cells, and put it back in, and 92% of the kids that get this treatment go into remission. And as we scale up and build this new building where we can provide this treatment to more kids, we now have to move into the realm of the FDA and things like 21 CFR Part 11 compliance, and that's a whole nother level of compliance that I spend a fair amount of time thinking of and struggling with. So that's a long way of saying, if I could just have a flip-on switch, say this is compliant. I know it's not that easy, but to have a compliance system that's GMP, GXP ready, 21 Part 11 compliant, HIPAA compliant, that would be my dream.
Okay.
Just flip us.
All well noted and recorded.
And everybody agrees.
So you mentioned sort of this ability for people to build from what's been done instead of having to start over again, and that touches on just the pace of innovation, which we all know is happening so fast. And so a lot of times at Amazon Web Services, we love to talk about how the cloud enables you to experiment and fail fast. And I just want to sort of throw that at you and hear what you all think about that when we say that. What does that mean to you? And how has that helped in your work?
Yeah, I see one of my colleagues out there, Yuli Hardy, who does our health information exchange, and she's been able to innovate, support pediatricians in the community, sharing data from Seattle Children's in a compliant manner, and be able to innovate in AWS. Again, not relying on the infrastructure within Seattle Children's, the on-prem, but able to innovate quickly. I think of our research team building that Hadoop platform very quickly, not having to go out and buy a bunch of clusters, but actually just program it within AWS and it'll be up and running.
Mm-hmm. Yeah, I think we're in a similar spot, and I have sort of two answers. One is kind of from our product perspective and how we enable our users to do that path, because they can. When we learn of something new, we can spin up something on Amazon and put it out for them to try, put it out for them to play with, so that they can fail fast and learn from their mistakes. And our platform is really geared at reproducible and repeatable research. And so we try to build in tools that let them share their failures, share their successes, share their processes in a way that lets others pick them up and start from there instead of rewriting everything from the ground up. But then internally, for us, we're a small nonprofit. We don't have a giant venture budget. We don't have a giant engineering team. For us, there's some huge benefits to being able to use things like auto-scaling technology to be on AWS as such a, we don't have to worry about the infrastructure. And so this sort of meta efficiencies of our own problems are, we just don't have to worry about them as much. And we know that, in those rare cases where AWS goes out for a couple hours, most of the world is out too. It's fine. Nobody cares about us at that point because Gmail's down and everything. So it's fine. Whereas if we had to monitor banks of servers or go out and buy new hardware when we wanted to scale up or physically acquire these things, it would take us so much more money and time, and we would just work slower, I think. So there's these dual tracks where we can, if we see something cool and new, we can try it out, we can spin it up rather quickly, we can get it in the hands of all of our users so that they can try it out quickly. And then if it doesn't work or it's not the right thing, we can turn it off and try something new, all pretty low risk. So I think that's really something pretty great.
I think that's an interesting side effect of wanting to fail fast. So when you want to fail fast, that often means that you don't talk as much, right? Because when you talk a lot, you want to do it really well. And everybody wants to include their thought and their view. And if you say, oh, this is going to be a big mess and it's going to be all failing and let's just do it and get over with it, then you roll it out and surprise, surprise, somebody, it's not going to be the best thing ever, but somebody will find it useful. And there's actually, the result is we've tried to fail fast on many things, but I cannot report a failure just yet, right? So when you do something, it's not great, but somebody will like it, and because the effort to do it was not high, you can actually deliver that to them. So my concern is, of course, if you have now a long list of half-baked things running, then at some point this will all collapse. But we already intended it to collapse in the first place, right? So if it then finally collapsed, maybe that collapse is not as bad as we thought it would be. Mm-hmm. So I cannot report a big failure just yet, but I'd like to do that at some point.
Interesting. Good. Okay. Yeah, why don't we open it up and have some questions from the audience, if there are any.
So I have a question. It's a bit more cultural than anything else. Can you hear me? No, there we go.
We can't see you, but we can hear you.
I'm okay with that. So the question is, are you and your researchers able to ask bigger questions because you're not constrained by the technology you have on site? Is that changing in your culture? Is that something that's good?
Yeah.
Are you seeing this? Is this?
I can take this directly back to my slide with proteomics. Before that there was a computer under the desk, and they could run examples in sequence. And they did that. And the computer was always overloaded, and sometimes it was idle. And now they had the cloud, and they would also submit the jobs in sequence. So they would wait until one job had finished and then start the next one. And then we had to have a discussion on the fact that, well, the cloud is actually a little bit bigger than you thought, and you can actually submit one job, and then 2 minutes later you can submit another job, and they will run in parallel. And of course, we take this all for granted, but if nobody tells them, and computer people are not always known to be the best communicators, we're working on that, then that is not clear, right? So that was it has a direct impact on the workflow, it has a direct impact on deliverables, it has a direct impact on throughput, and on publications. In our case, the product is a publication, so this publication is delivered earlier, and researchers are also competing with other researchers, so that's kind of what do you want to call time to market.
Yeah, for us, I have two examples. One is with our partnership with Genospace, which is built on AWS. We were able to load up 300,000 patients' data that was de-identified from an electronic health record and allow a GUI interface of which our researchers then could explore the data from our electronic health record. Previously, they would have to submit a ticket, wait weeks to months for an analyst to pull the data from even simple counts. And now they can iterate in real time and use this interface to look at structured data and prepare their grants quicker to see if they have enough patients that potentially could qualify for a clinical trial. Again, they can do that real time without the need of an analyst. Analysts available to help support and train them if they have questions, but they can do it at midnight when they're writing their grants. The second example I have is, again, with our early trials with Hadoop and with Cloudera, building their genomics accelerator, partnering with them and building that. We were able to bring electronic health record data integrated with genomic data to really augment that and make that richer data set. To give you a comparison, one of our first researchers that we work with has stacks and stacks this high of manila folders with clinical data of his patients and hard drives of his genomic data. Now is within one source on the cloud of which he could explore and ask questions in real time, pull annotations from the publicly available repositories. Again, something that we couldn't have done with on-prem hardware.
Yeah, and I think that the availability of for many researchers, free options or shared code repositories or things like that enable people to start a couple steps ahead rather than starting from sort of the beginning of their exploration. And I think that time to market is a good analogy because I think you could have described the research cadence as being very linear almost, starting with an idea and a lit review and some funding, maybe, hopefully, or maybe you do some research for free first and then you get some funding and then you end in a publication. And I think that's still true, but we're starting to have branches along the way where people are going to start sharing their data earlier or potentially sharing their analyses earlier, or maybe if they're not and they're only sharing on publication, they're sharing more. They're sharing more of their raw data, they're sharing more of their analysis code, they're sharing more of their processes so that someone else, instead of just reading the results, I don't know how many people in this room, maybe a lot, have tried to reproduce an experiment from a single journal article. I mean, it's going to take a minute. It's going to take a long time, actually. But being able to actually say, okay, here's the data, here's the code. Okay, I understand the results much more deeply. I can start my research here now instead of 17 steps back. And I think it's not yet the norm, but it's getting there. And I think that's where we're headed, where if you're not sharing your raw data, de-identified, of course, and if you're not sharing your full analysis, then you're not sharing your full results. And I think that's where we want to go so that we can start to work more efficiently and more productively in the research space.
Great question and great panel. So I think we're running a little bit over time. I just want to thank all of our panel participants here. They will be here, so if you did want to ask them questions, please feel free to find them. And just thank you for joining us. So
thanks, Mia.
Yeah, thank you.